Hello and howdy, ladies and gentlemen. Welcome back. We're looking now at question 14 on our 2009 Pascal. And if you haven't tried this one, I would encourage you to pause the video and give it a bit of a try. And as always, if you'd like a copy of the contest, you can click the very first link in the description. Now, what does question 14 have in store for us here? In the diagram, O is the center of a circle with radii OP and OQ, and we've got a nice little right angle here as well that we can see on the diagram, and they're actually telling us the radii 5. And I also notice we got the shaded area, so maybe we're trying to figure out the area. But, the perimeter of the shaded region, including the 2 radii, is closest to. So we're not looking for area, we are looking for the perimeter of our shaded region, and they say closest to. Now, as soon as I see closest to, I start to think I should grab my calculator. Okay? It makes me happy when I bring my calculator, because closest to, rounded to the nearest tenth, these require me to actually do the calculation and not have it exactly like something like 2 times root 7. They want to know some of the decimals so that I can round things, and that's really best done with a calculator. Now, it's not always required that you need a calculator. For example, I suspect there'll probably be a pi somewhere in our answer. If you know pi to a couple decimal places, well, you don't need to know all of pi, but 3.14, 3.1415 will usually get you close enough if you're willing to do the calculation. But why bother when we have a machine that does that for us? Okay? So, if you've forgotten your calculator, that's okay. You could probably do this question if you knew a little bit about pi, but really don't forget your calculator, because it can save time and it really helps you on a question like this. Okay, so what can we do? Well, this shaded area here is a full circle with a quarter of it, 90 degrees out of a full 360 degrees, so a quarter of it taken away. So we could, for example, draw this sort of Pac-Man looking figure. There's O, and P, and Q. Now, I'm not the best at figuring out formulas for 3/4 of a circle's circumference or something like that. You absolutely could. There are formulas for that. But you might want to think of this instead as, well, what if I just figured out the full circumference, took away this purple arc, and added in the 2 radii? We know the 2 radii are both 5. Okay, so that might be a good plan of attack. Now, in either case, either you do the purple thing, or instead you could just figure out this whole green arc and add on the 2 radii. That's fine as well. But in either case, you're going to have to figure out, well, what's the perimeter or circumference of a slice of the circle. Okay? And it all depends on what slice or what angle you've got left. So here, inside we have a full 270 degrees left because we take away a 90 degrees. So in any case, in any situation, if you've got a circle and you cut out a portion of it and you're just left with some sort of theta. Theta is your angle, and that's the amount of slice that you have or that you're looking at. This circular arc here is going to be a fraction of the total circumference of the circle. Now, in terms of the radius, what's the circumference? Well, it's 2 pi times the radius. Now, there's 360 degrees in a circle. If we're just considering theta degrees, so we might call this the partial circumference, it's going to be, not 8, theta out of the full 360 degrees times the circumference. It's just a fraction of the circumference, and that gets us a slice of the circle. So as I say, we can do this question 2 ways. We could take the full circle, so that would be 2 pi r, and r here is 5, so that's 2 pi 5, or 10 pi, and subtract off this quarter bit, and then add on the 2 radii. Or we could figure out this outside bit, which is going to be 3/4 of the circumference. 270 out of 360 is 3/4, and then add on the 2 5s. Either way is fine. So I'm going to say the perimeter here is 270 degrees out of 360 degrees. So I'm taking the full bit and then adding on. So I'm taking sort of the green path as I have it highlighted. 2 pi times 5, and then we're going to add on 2 copies of the radii. We can't forget PO and OQ. So this will be 3/4, 10 pi, so this will be 30 pi over 4, or 15 by 2 pi plus 10. Now this is the exact answer, but they are not interested in the exact answer. We need to round this off. Okay, so I'll get the actual answer with my calculator in a moment, but I just want to show that you can actually round it pretty well if you just know pi. So pi is about 3.14. In fact, we can probably get away with just using pi is around 3. Pi is pretty close to 3. Okay, so we try 3, and then we add on 10. So we get 45 over 2, which is 22.5. We add 10, so we get about 32.5. It would probably be a little bigger because we don't have this 0.14, 1592 stuff. But let's look at our answers and see if there's one that's really close to this. Because if we take a look, we got 34, 41, 52. All these are very, very spread out. And so my answer is going to be A, 34. Okay, that's what we're going to get. You know, we were a little short, but that's because we didn't use the full pi. Now, if I grab my calculator here and actually perform the calculation, 15 divided by 2 times pi plus 10, I get 33.56, and that's even closer to 34. But we got the same answer either way. So 33.56, something, something, something. I'm just rounding it up to 34, and that is an answer of A. Now, I do want to double check my work just because I'm a little suspicious because all these numbers here are so much bigger. I picked the smallest answer. That doesn't mean it's wrong, but it does make me want to go back and double check. Did everything make sense? Okay. So we want the perimeter of the shaded area, so I've got this full part here, which is 270. It's going to be 3/4. So 3/4. 2 pi, r was 5, 2 times 3 is 6, times 5 is 30, 30 over 4 pi, and that is 15 over 2 pi. And then, yeah, we have to add on OP and OQ, and so that's 2 copies of 5, which is 10. So 15 over 2 pi plus 10. Yeah, that's the right answer. Okay. Just a little nervous there because all the numbers were really big and far away. But okay, we double checked it. I confirmed it to my satisfaction. And that was, what was that, question 14? Was that 14 or 13? That was question 14. Up next will, of course, be question number 15, and I'll see you there.